This is DPedal version 3, a foot pedal I designed to assist with my repetitive strain injury. I mainly use it for scrolling through documents and code with my feet, as those activities are particularly troublesome for my hands. The original DPedal is this thing. I used it for years, and someone else even built their own DPedal based on the designs I published. While this original design served me well, it has a lot of problems preventing wider usage. It's expensive, fragile, and a pain to configure. To fix these issues, I completely redesigned everything for version 3. Not only does it now cost 60 AUD to build a single unit, down from 98 AUD, but the new design is more robust and easier to use. So let's get into how I achieved that. Reducing the height of the pedal is a win in every dimension. It's more ergonomic, consumes less plastic, and increases portability. The biggest win was replacing the Cherry style switches with Choc V1 switches. I also realized I can order thinner PCBs. Standard is 1.6mm, but I changed to 1.2mm. And finally, I reduced the height of the bottom part. The new bottom part is weak by itself, but when combined with the thick top part, the pedal is very sturdy. This approach may sound obvious, but when I designed the original DPedal, I wasted a lot of height by ensuring each piece was sturdy on its own. Here are some other steps I took to improve the strength. I used screws and nuts instead of a loose press fit. I avoided exposing the PCB, like the old design did. Firmware flashing is now done using a SIM tray opener to press the flash button. I replaced the 3D printed buttons with mass-produced ones, and raised up the top surface to surround and protect the buttons. The pedal is now strong enough to throw in a backpack without worrying about bits snapping off. I actually took it with me on a recent work trip. The original DPedal design relied on PCB assembly performed by a manufacturer. This is expensive as the assembly process has a large setup cost and so requires large orders to do economically. Previously, the minimum order was $80 for 5 PCBs, of which 2 are assembled, and the remaining 3 boards were useless, as the components were too small to hand solder. The new design still uses a PCB, but skips the assembly stage of manufacturing. Instead, we buy 5 PCBs for $12, and a single Raspberry Pi Pico for $12. Then we solder the Pico to the board. This is much cheaper. If you live in a country where you cannot cheaply buy PCBs, you can always directly wire up the components to the Pico with 30-gauge wire. But that is pretty fiddly, so if you can, I recommend using a PCB. I originally tried this with wire much wider than 30-gauge, which I had to abandon as it didn't fit. I'm really happy with all of these hardware changes, but the software still needs a lot of work. I quickly wrote a basic firmware using the Embassy Rust embedded framework to prove the hardware works. But I didn't want a repeat of the old situation where configuring on Windows requires fiddling with USB drivers. So I sketched out some designs for a web-based configuration GUI and then started hacking away. While there's still more features I want to add, at this point I have an MVP I'm comfortable with shipping. This new tool can configure the DPedal to make any mouse or keyboard input without any special drivers, just by visiting the DPedal website. Here I'm setting the up and down buttons to A and B. The web configurator is written in Rust, compiles to WebAssembly, and uses the relatively low-level WebSys bindings. I wanted to avoid pulling in a large GUI framework to keep the binary size and therefore load times small. Using Rust for both the device firmware and the web app means I can share the same config type definitions between them both, which is super cool. In a previous video, I talked about using the FIDO protocol to support communication with any browser. But it has some weird UX consequences, so I chickened out and went with WebUSB instead, requiring Edge or Google Chrome. Okay, but what does it actually look like? To build a DPedal, the steps are: print the parts, solder the sockets and Pico to the board, place the PCB between the bottom and top, screw them together, push in the switches, secure the D-pad, pet your dog, push in the buttons, and done. But that's just a summary. If you want to build your own, you should check out the full build instructions at DPedal.com. This includes the parts to buy, the parts to print yourself, and how to solder and assemble them together. The guide is aimed at beginners and doesn't even assume you own a 3D printer. You'll also find a link to my Discord where you can discuss the project. It would absolutely make my day to hear back from anyone who is building one. Thanks.